Hello, in this lesson, we are going to talk about tangent, graph, and domain. Well, we like to review the definition of function one more time, as always, right? Because this is the guiding principle that for us to work with our functions. And a function is a rule that assigns to each input in domain exactly one output in range. And when we are talking about, trig functions, and we want to study their domain and range, and we know there are 6 of them right now we're talking about. And if we consider arcsine, arc cosine, and we have more, right? So now let's look at the stage set. The stage set is that we have the 3 pillars of trigonometry, right? And all the inputs to 6 trig functions are measured from the standard position. The 6 trig functions we refer to sine, cosine, tangent, cotangent, secant, cosecant. The first one, of course, is angle measurement again, okay? Positive angle are measured counterclockwise from the standard position, and negative angles are measured clockwise from the standard position. Reference angle, right? A positive acute angle between terminal and the x-axis. Definition. Today, we're going to discuss definition for tangent, right? So we're going to remove the sine, cosine. Okay, we have discussed sine and cosine, and we have a bunch of special angles that has worked out. And so with that understanding, right, if you look at the unit circle, it says the point on the terminal side of A other than the origin, still the same setup. But tangent of an angle, okay, is the ratio of y over x. Take the example, okay, of pi over 6, right? Tangent of pi over 6, right? How would we find the ratio? Y over 6, right? So we go by definition. We measure the angle pi over 6 from the standard position, counterclockwise because it's a positive angle. So terminates here. And I probably should not use this color, okay, because that gold color is reserved for our arc length, okay? So here's the terminal of pi over 6, right? And we pick a point on the terminal side of the angle pi over 6 other than the origin. So that point, we already got it, right? It crosses the unit circle. So we get this point, okay, this point. And on this point, we studied the red number is cosine value, the blue number is sine value. And these two numbers are also x and y respectively. So this is x, right? So this piece is x, and that piece is y, right? So we got x and y, okay? Now, what is tangent pi over 6? Y divided by x, right? Y divided by x. So this is x, right? And the other one is y. So x and y are there, right? One is red, one is blue. So you can see to find the tangent of these special angles, which you already have these numbers worked out, we simply just have to do what? Just divide the blue number by the red. Divide the blue number by the red number. Okay, so y over x. In this case, y is half, and x is √3 over 2. And then we reduce. Okay, in fact, we can work out all of these tangent values about the unit circle for these special terminals. And then how about for non-different non-special terminals. But you just apply definition. As long as you can identify a point on the terminal other than the origin, right? By definition, we can always find something. So now let's reduce this number. Half, right? Over pi over root 3 over 2. To reduce it, we're going to multiply 2 over 2. 2 over 2 is 1. Anything times 1 stay the same. So after this reduction, we're going to have 1 over square root of 3. And then to rationalize it, we're going to multiply by root 3 over root 3. Okay, as a result, 1 times root 3 is root 3. And root 3 times root 3 is root 3 squared. Root 3 squared is 3. So tangent pi over 6 is root 3 over 2. See, we have input pi over 6. After tangent function, we get output root 3 over 2, root 3 over 3. We can do these for all of these points, but be careful, be careful. We're taking the blue number, divide by the red number. So at a point when the radian is 0, well, 0 divided by 1. 0 divided by 1 is 0, right? So now if we're taking tangent 0, we certainly will take the 0 divided by 1, and that's going to be 0. That's not a problem. So we do 1 by 1, right? And input, output, input, output. And of course, all these input output will formulate points, right? So let me put them in the proper order, right? Now, input output, we know that input output will make points, right? And we're gonna graph, right? We're gonna do the graph. How do we do the graph? So let's look at the first, just look at the first quadrant, right? If we look at the first quadrant to find all the tangent, okay? And we're gonna plot points, right? So for that one, we get 0, 0, right? So we have, I'm gonna move it down. That's for 0, 0, 0, 0. I have prepared a graph right there. Okay, so here we got 0, 0 on the graph. Just one dot, right? But it means when the input is 0 degree or 0 radian, the output is, tangent ratio is 0. And the next one, right? We just find out tangent pi over 6. Okay, tangent pi over 6 is square root 3 over 3. So now how do we graph this? We graph them in almost the same way. Is that pi over 6, okay? Pi over 6 is the input. It's terminated here, right? It has a terminal crossing the unit circle at the point of root 3 comma half, root 3 over 2 comma half, it terminates here. And there is an arc length. Okay, this arc length will be used as the length pi over 6 here. You see the pi over 6. So this arc length, oh, that drawing was so ugly. Let me make it better again. Okay, so that pi over 6 arc length is the same as the pi over 6 arc length here. And the ratio, so input, output, the ratio is the vertical. which is it's the ratio of the blue number divided by the red number. So this is how we making the graph. This is how we make the graph. Okay, so let's look at another example. Let's look at another example. Right now, we're still working on the first quadrant, right? Now, the first quadrant, we done pi over 6. Let's look at pi over 4. So what is tangent pi over 4? Pi over 4. Tangent pi over 4, right? If we look at this unit circle, right, we will go by definition, right? Go by definition, then we're going to measure an angle from the standard position at a pi over 4. You see, we constantly just use the definition, pi over 4 here. Pi over 4 terminates over there. And there's a point on the terminal, which is also crossing with the unit circle, which give us the cosine and sine, and x, y, right? The red number is x, the blue number is y, and these two numbers happen to be the same right now. So tangent pi over 4 equals to root 2 over 2. The blue one divided by the red root 2 over 2. Okay, and of course that's equals to 1. So tangent pi over 4 is equals to 1. Okay, and now we're going to plot that points. And here I just found when I was doing that, I made a mistake. It should be 1. Okay, so let me quickly correct it. Okay, that should be 1. How did I? Which one? Oh, the point right here. It should be 1. My bad. Okay, there we go. Got it. Okay, so input pi over 4 for tangent function, the output is 1. So the point is input pi over 4, output 1. So I use a purple color now, right? And pi over 4, once again, okay, is the arc length, measured arc length, right? So let me make it just a little bit thicker. You see, it's consistently the same theme. Arc length and the tangent ratio. Arc length, right? The golden arc length is straighten up and measure from origin horizontally, and the vertical is the tangent ratio. And tangent ratio at pi over 4 is equals to 1. So point by point, we're doing this. We're doing this, right? We're doing this. And next, okay, let's look at pi over 3. So we're moving towards from 0, right? Our terminal is not this color. Okay, let me change the color, right? So from 0, we're going counterclockwise from pi over 3 to pi over 4. Now we are approaching pi over 3. Along the way, you can see the red number is getting smaller, the blue number is getting larger. Do you see that, right? The red number, the cosine value is getting smaller and smaller. If you recall cosine curve, right? From 0 to pi over 2, in that interval, cosine indeed is decreasing. And sine from 0 to pi over 2 actually is increasing. You see the blue number is increasing. Increases, and by the time it reaches pi over 2, sine pi over 2 is 1, cosine pi over 2 is 0. That means as we are approaching, okay, as we are approaching pi over 2, okay, we're getting closer. And in those cases, the cosine value is getting closer and closer to 0. And the sine value is getting closer and closer to 1. I want you to see that. Okay, right now, just have an impression, and we're going to come back to it. All right. With that said and done, let's look at tangent pi over 3. Tangent pi over 3. Okay, I think I need some corrections there as well. Okay, this is pi over, this is root 3. Okay, so that correction should make it better. Okay, now for tangent pi over 3, tangent pi over 3, tangent pi over 3 is the blue number divided by the red number, right? It's blue number divided by the red number. And the arc length is pi over 3. So we're going to do root 3 over 2, root 3 over 2, and the denominator is half. Okay, and if we multiply the top and bottom by 2, we get root 3. Okay, we get root 3. So now let's plot the points. Let's plot the points, right? So when the terminal is right here, and we're measuring this angle counterclockwise and terminates overlapping this terminal, that's the angle is pi over 3, and pi over 3, okay, that arc length stretched, okay, stretched straight, we get a pi over 3 right here. You see, it's very consistent with sine, cosine, and the only difference is the ratio is different, right? So this point is pi over 3 square root of 3, input, output, and the square root of 3, square root of 3. This purple number has the height of square root of 3. Now, okay, next, naturally, we're going to measure angle to what? To pi over 2, yes. But we have a problem here. We do have a problem here. If we touch pi over 2, we get a blue number 1 and red number 0. 1 divided by 0 is undefined. 1 divided by 0 is undefined. So this tells us something, okay? This tells us that pi over 2, okay? This tells us, so let me go to the next line. Okay, we don't need that. Maybe I'll just keep that. Anyway, for tangent, right? Tangent pi over 2, because we have a 1 divided by 0 case, so this is undefined. So tangent function is undefined at pi over 2. That is, it cannot take pi over 2 as input. 1 divided by 0 is undefined, okay? Doesn't exist. Therefore, for the input of pi over 2, there's no output, right? According to the definition of function. If for one input there's no output, if there's no exactly one output, then that input number should not be in the domain. It's out. Therefore, domain, right, in the domain of tangent, it should not include pi over 2. Okay, it should not include pi over 2. Okay, so then what? We still have to observe the behavior of this ratio, this function tangent, before it reaches pi over 2, isn't it? Right? Before it reaches pi over 2. So what can we do? Right? And so when the angle approaches pi over 2. So what we're trying to observe is that when the angle, of course, we know the angle can never be pi over 2 now, right? But we can get very, very close to it. When we get closer and closer to it, what will happen, right? What will happen? That's what we want to observe. Okay, so this is the question. So next, we're going to, you can use your calculator, okay? And we're going to observe these situations. We're going to observe these situations, okay? So now, what I would do, we're going to observe the value, the values of tangent, okay, as the angle approaches pi over 2 from smaller than pi over 2. Okay, we put a negative sign on the shoulder indicating that we are approaching pi over 2 from smaller than pi over 2. On the number line, suppose that we have the point pi over 2. Okay, so I'm going to mark the point pi over 2. Pi over 2. Pi over 2. We know that tangent cannot equals to, you cannot take that input, right? So I'm going to put a circle over there. There's a circle, right? So maybe I can make this a red circle, right? I'm going to make it a red circle. Forbidden. Okay, we cannot go there. We cannot assume that value, but our angle can get as close as possible to it, right? So we're going to observe how the ratio of tangent behave when we take a numerical, when we take values, input values closer and closer to pi over 2. Okay, so that's what we're going to observe. Okay, so with that in mind, I'm going to make a little table. Okay, I'm going to make a little table. And I would like you guys to also set up a table. Okay, maybe I only need 2 rows, maybe a couple columns. Okay, so the input, angle A, tangent of A, and A is approaching pi over 2 from smaller than pi over 2. And we are also going to make a table which we're going to use degree, just in case some of you is more used to see it with degree. So degree, 90 degree, right? Wait, 90 degree. But from smaller than 90 degree. Okay, so we're going to choose some values. Okay, let's do the degree from less than 90 degree, right? Less than 90 degree, we can think of like 88 degrees, 88 degrees, right? Tangent 88 degrees, what does that equal to? Tangent 88 degree, what does that equal to? It should give me a numerical value here. It doesn't? Well, if it doesn't, I'm going to bring it outside because this software, in terms of using it. All right, it's equals 26.636. These are non-special values, right? 28, sorry, more than 28, right? So this is if you work with degree. And let's work a couple on the degrees, right? Suppose 88 degrees, how about 89 degrees? 89 degrees, right? So let's look at tangent, 89 degrees, okay? Check on your calculator, right? So your calculator should give you some numbers. Wow, 57, more than 57. So what do we see here is that as we as our angle approaches 90 degrees from smaller than 90 degrees, the tangent ratio is getting larger and larger yet. You can see from 88 degree to 89 degree, it's only 1 degree more, but it's almost double the previous ratio. Okay, so let's do an 89.1. How about that? Right, we're even closer to 90 degrees. So I'm going to put this degree there. So let's look at tangent 89.9, right? 0.1, sorry. So this is a 0.1. So what will be that ratio? That ratio, I increased just a little bit, 63.657. Okay, 63.657. Wow. How about I'm going to make 89.01 degree. Okay, just a little bit closer. Okay, just a little bit closer. Or guess what? How about we try 89.9? Isn't that closer? That's right. That will be closer, right? And this one I'm going to do 99. So let's see what will be this angle, because that's so much closer, right, to 90 degrees. So I'm going to do 9. Why did I think of that earlier, right? There we go. So what is the ratio? Wow, 572.96. There we go. How about 89.99 degrees? Let's see for ourselves. $5,029.6. My goodness, right? So tangent, right? 89.99 degrees, which is so much closer to 90 degrees. From smaller than 90 degrees, you can see we get these values, right? Let's look at the radian. I know a lot of us are not quite used to radian, but since we deal with radian, you know, we need to deal with radian anyway. So let's do some radian degrees, radian calculation. For your calculator, just go ahead using it. Go ahead, use it. You know, try to make sure you can work with the radian too. Okay, maybe find the menu if you don't know how to use it. But anyway, we are approaching pi over 2 from smaller than pi over 2, right? Between pi over 3 and pi over 2, there are really not many special angles anymore. So what do we do is, this is time we really have to rely on calculator, right? So what I would do is that I'm going to assume A, okay, the angle is going to be pi over 2, just a minus a number. Say I'm going to minus, say 0.1. How about that? Right? It's a little smaller than pi over 2. So then we're going to look at a tangent of this angle. Tangent of pi over 2 minus 0.1. Right? This is the angle that's smaller than pi over 2. Right? It's close to pi over 2 enough. 9.9666. There we go. So tangent of pi minus 0.1. So how about we choose another angle, right? Another radian, which is minus 0.01, right? So what would that be? Even closer to pi over 2, right? 99.997. There we go. Okay, so how about we choose an angle that's even closer to pi over 2, but smaller than pi over 2. So in this case, let's see what we get. 1,000. approximately. I think it's approximation. Okay, there we go. So what have we seen? What have we seen? As we're getting closer and closer to pi over 2, tangent is approaching positive infinity. Okay, so what we have observed, right? What we have observed is as a approaches pi over 2 from smaller than pi over 2, right? What we found is that, so we can say as as the angle approaches pi over 2 from smaller than pi over 2, tangent of A is approaching positive infinity. If you'd like to put a positive sign, it's optional. So how is that viewed in the picture, right? In this picture, certainly it's very difficult to graph. It's very, very difficult to graph. So I'm going to use, Desmos. Okay, Desmos picture is not ideal. Okay, it's not ideal, but it's a little bit helpful. It's a little bit helpful. Okay, so now I'm going to share that. I'm going to share that. Okay, so pi over 2. For pi over 2. Where's pi over 2? Right? So I'm going to draw pi over 2. This line. Okay. Wait. Pi over 2. You see the purple line? You see the purple line. Right? So what do we just plotted? Right? So let me plot a couple points, right? We are familiar with. For example, pi over 6. Right? The ratio on tangent is going to be 1 over root 3, right? Square root of 3 over 3, right? Sometimes people write 1 over root 3. That's not a problem. Okay, so that's pi over 6, right? And let's look at another point. Pi over 4, which we did, right? And the ratio is 1, no problem. We got that pi over 4 right there. And pi over 3, and the ratio is root 3. And there we go, right? We got these points. And then as we're getting closer and closer to pi over 2, as we're getting closer and closer to pi over 2, our input is getting closer and closer to pi over 2. So I'm going to use an orange color, right? Because this is arc length approaching. Make it thicker, right? I'm going to make it thicker. The arc length is getting closer and closer to pi over 2, but not equals to pi over 2. You can see the curve is just shooting up, okay? So now I plotted a couple points I wish to show you, okay? Pi over 2 minus 0.1, we saw that point, right? You can see, you don't even see these 2 points. I have them both labeled. So now I'm going to remove this arrow. Well, I can just keep it there to see when it bothers us, we're going to remove it, okay? So I'm going to show you, there's a red point, there's a green point. So we're going to, this is on the scale, on the Y scale, you see 1, 2, 3, 4, 5, right? If we just keep going up, oh, there's 1 here, right? Okay, that's pi over 2 minus 1, tangent pi over 2 minus 0.1, right? That's the red dot right there. And next, if we keep going, you see the purple, the blue tangent curve is getting closer and closer to it, and we're still not there. We're still not there. Okay, we're looking for the red dot, the blue dot, the green dot, sorry, the green dot right there. Okay. Oh my God, is it getting closer and closer and so much closer? they're not supposed to touch, okay? They never touched it, but it get infinitely close to that purple. I think, I don't know if I can ever find it. I think we can find it because I prepared for us to see that before. Oh, this is going to be very, very high. You can see the curve, it just finally. Okay, so you can see the input is not pi over 2, is smaller than pi over 2 by 0.01. And the ratio is 99.997. If we use a number we calculated like 1,000, it's going to take a long time for us to detect that point, right? To actually even see that point. But anyway, so you can see that it's getting larger and larger, and the tangent ratio, as we, as the angle approaches pi over 2 from smaller than pi over 2, the tangent ratio can be as large as you want, can be as large as you want. So let's go back here. And this is the, now some of you, I think, probably will be whispering the purple line as a vertical asymptote. If you're saying that, you're absolutely right. You're absolutely right. Okay, so that is the case. So as x approaching negative, as the angle, okay, the arc length approaches pi over 2, tangent ratio approaches positive infinity. Now the question is, how about on this direction? How about on this other direction, right? Negative pi over 6, negative pi over 3, and how about negative pi over 2, right? Can we assume these values? Can these values be in the domain? So now we're going to look at these. Okay, so let's go back to our curve. Okay, so if we now put the tangent curve on this piece together, right? I mean, tangent curve for you is really just at your fingertips, right? Tangent x. We get that easily. No problem, right? So the piece we're talking about right now, I need to make just a little bit of adjustment, right? So we can see a better view. So this one here, I'm going to make it like maybe -5 to +5 vertically. And in the other direction, I make it a -2 to +2. So we just see one piece. Okay, we just see, kind of, well, there are many pieces, as you can see from the picture, right? So we have plotted these dots. And the vertical asymptote, which we just have discussed, right? Which is pi over 2, is something the curve will never touch, but it can get infinitely close to it. Okay, so we're going to draw that vertical asymptote. And that's going to be just like that. Okay, so for vertical asymptote, I'm using red right there. You can see I'm going to put the points of pi over 6. Okay, and that ratio is √3/3. Right, that's a dot. We can use green dot. Add another one, pi over 4. So these are the special values, but you need to understand there are many more in between. right? And here's pi over 3. So we plotted these points as we just did. And we got these dots on the curve. Okay, pi over 6, root 3 over 3, pi over 4, 1, pi over 3, root 3. Okay, input, output. So that shows our calculation earlier on. And these calculations, however, reflected that as we're getting closer and closer to pi over 2, the ratio really shoot up, okay, to 1000. So that's what happens. Okay, you will need to know this fact when you are in calculus classes. Okay, so as the angle approaches pi over 2 from smaller than pi over 2, tangent pi is going to be approaching positive infinity, which we have mentioned that fact, right? So when angle is approaching pi over 2, okay, you can approach pi over 2 from either direction. So we have to indicate which direction it approaches pi over 2, right? Because you can see if approaching pi over 2 from larger than pi over 2, it is not going to be approaching positive infinity, you see, from here, right? It's approaching negative infinity. So here we have to specify from smaller than pi over 2, okay? And tangent of that angle approaches, the ratio approaches infinity. Okay, so we're done with the first quadrant. Ooh, we're done with the first quadrant. And next we're gonna do the fourth quadrant, When we do the fourth quadrant, guess what? We notice that at a negative pi over 2, we encounter -1 divided by 0 for a tangent ratio. So negative pi over 2 cannot be in the domain as well, okay? So negative pi over 2 cannot be in the domain. And of course, 3 pi over 2, which share the same terminal, cannot be in the domain too. So there'll be a lot of angles that terminates on this y-axis. None of those angles can be in the domain, right? So so what are those angles? What are those angles, right? What are those arc lengths, radians, right? So we realized, right, before we plot these points, right, on this side, and we realized the following, okay? Tangent the domain of tangent A cannot, the angle cannot terminate, okay, on y-axis, period. Okay, but y-axis has 2 directions. And that means it cannot be pi over 2, right? It cannot be pi over 2. It cannot be 3 pi over 2. It cannot be 5 pi over 2. It cannot be 7 pi over 2, and so on and so forth. And -1 also, okay? It cannot be negative pi over 2, cannot be negative 3 pi over 2. It cannot be negative 5 pi over 2. So it just keep going, okay? So we figured that the domain of tangent cannot be, okay, so what the symbol for cannot be? Cannot be positive, negative pi over 2. Okay, it cannot be positive or negative 3 pi over 2. Okay, it cannot be positive or negative 5 pi over 2. It cannot be, we can keep going. Do we see a pattern? It cannot be positive or negative 7 pi over 2. What do we see here? What do we see here? It cannot be 1 times pi over 2. It cannot be 3 times pi over 2. It cannot be 5 times pi over 2. So in words, right, this input cannot be odd number multiple of pi over 2. Does that make sense? Cannot be odd number multiples of pi over 2. But how do we express odd number multiples? How do we express odd number? Okay, and this is how we express odd number. So A cannot be odd number, can be expressed as 2k plus 1. 2k minus 1 works too, of pi over 2, where k, okay, where k can be any integer. Okay, to help you understand this, for example, if k equals to 0, right, then 2k plus 1, if you substitute k by 0, you're going to get a 2 times 0, and you end up with pi over 2. Okay, if you choose k equals to -1, right, that's integer. And then 2k plus 1, k will be replaced by -1, right? 2 times -1 is -2. -2 plus 1 is -1. -1 times pi over 2 is -pi over 2. So we got -pi over 2 covered, right? We cannot equals to plus minus pi over 2. So we got, so this form get plus minus pi over 2 covered. And if we keep going, right? So this is for k equals to -1, right? Yeah, there. So how about for k equals to 1? If we choose k equals to 1, 2k plus 1, k equals to 1, and we will get 2 plus 1, that's a 3 pi over 2. 3 pi over 2. Right? So we got a positive 3 pi over 2 covered, right? It cannot be that. And what if k is -2? If k equals -2 and k is replaced by -2, right? And this is going to be -4 plus 1, -3 times pi over 2. This is going to be -3 pi over 2. So you can see now we got positive and -3 pi over 2 covered, which got them covered. Okay, so keep going. We found that and this form will cover plus minus 5 pi over 2, plus minus 7 pi over 2 if we keep going. Okay, feel free to try this. Okay, so therefore we now conclude the domain of tangent will be expressed this way instead of that way. That way is right, but you like to know the general form. This general form covers all of them. Okay, it covers all of them. So now we got the domain figured out. What is the range? What is range? Obviously, the range, right? We realize from what we worked out, right? In the first quadrant, we realize it can be as large as possible. We don't know how small it can be, not yet, right? We actually got a glimpse of it, but we don't know how small it can be. We don't know how small it can be, right? So we know it can be as big as possible. And we try to find out how small it can be. Okay, so let's work on this, the fourth quadrant. The fourth quadrant. Okay, we already have the pictures for the fourth quadrant. Okay, so what are we going to do is that we're going to take this piece, right? We're going to continue our journey of calculating all of these, right? So what are we going to what are we going to calculate? We're going to calculate, right? Tangent. I'm gonna just take this unit circle, take the unit circle with me. All right, so it doesn't get too crowded. Okay, so we're gonna look at tangent negative pi over 6, right? That's in the fourth quadrant. Negative pi over 6. Tangent negative pi over 6, if we go back to our definition, which we always like to do that, right? We always like to do that. We measure from standard position clockwise, right? So there's a terminal, right? There's a terminal and there's a point on the terminal right there waiting for us. And therefore, we can take the blue number, divide by the red number, right? The blue number is -½ and the blue number is -½ The red number is √3 over 2. √3 over 2. And we end up with what? -1 over √3. Okay, and of course that is also negative. Oops, wait, I just deleted, right? 1 over √3. Okay, and rationalize it, right? You already know how to do it. So that's going to be 3 over √3 over 3, negative. Okay, so what would that, what will be that point, you think? That point is input, output, right? So if we put that in point, and that point is going to be -√3 over 6 and -√3 over 3. And we're going to put this point in the graph. Let's do it, right? So we're going to put that point in the graph, right? So we're going to add a point with the green dot right there. You see that new dot? You see that new dot right there, right? This is a negative pi over 6. And the ratio is -√3 over 3, right? So we just have a few more special point, and we're going to observe, right, how small it can be. It's coming up, okay? And negative pi over 4. So we're going to measure the angle as always, right? Always think of the definition, okay? Always think of the definition. We teach them, we really just teach the very basics, and that very basic is definition. So measure from the standard position clockwise, we terminate at negative pi over 4, and these two ratio is one is red and one is blue. The blue is -√2 over 2, and the red is √2 over 2, and you guys already know this value. So this ratio is -1, okay? And the corresponding point, the point is going to be negative pi over 4. And the ratio is -1, input output, right? So we're going to put that point in that picture once again, right? So we already have these dots. So we're going to add one more dot. You probably anticipated where it is going to be, right? Which is a good thing. And we're going to add another point. Boom. Right there. Okay. And then we will start to see the tendency, right? You already guessed it. You already guessed it. So one more special value, right? So this time is going to be tangent negative root 3, a negative pi over 3. Okay, negative pi over 3. And that ratio, right? That ratio would be, we're going to measure again because I really, really want you guys to keep in mind the definition. The angle measurement, the negative pi over 3 is a clockwise measurement and terminates here. We have a set of red number, blue number waiting for us. So the blue number is root 3 over 2 negative. The red number is half. So we take these two numbers and we divide them. We divide them. Okay, so we are getting root 3, oops. Root 3 over 2, that's a negative number. Okay, I'm going to put a negative sign in front of it. And the denominator, the blue number, no, negative root 3 over 2 with the blue number, the red number is 1/2. And that is equals to negative root 3. And the point we're getting here, right, is going to be, and that point with input output pi, negative pi over 3. And the output is a negative root 3. So we're going to put this number closer in the picture. In the picture. Okay, we already have these green dots here. So we're going to put this dot, okay, right there. Boom. You see, it's very similar to the situation on the other side, except this time we're going to be approaching negative pi over 2 from what? From larger than negative pi over 2. Okay, right. Now this side is smaller than pi over 2, but on this side, we're going to approaching negative pi over 2 from larger than negative pi over 2. This direction, because the right side is larger than the left-hand side, okay? We certainly will have, we already anticipated this is going to be a vertical asymptote, okay? So we're gonna draw that vertical asymptote, okay? But we just want to see how, what is the behavior? What is the behavior? Okay, so we want to observe. I'm going to take that picture with us. I'm going to take that picture with us. Right, we're going to observe the behavior of tangent curve. Okay, we want to observe, okay, the tangent ratio when the angle or the arc length approaches negative pi over 2. Okay, from larger than pi over, from larger than negative pi over 2, from this side. Okay, I know it's a little, you have to be very careful what we're doing. Okay, I should use orange color because orange color represent arc length. Okay, so we'll try to be consistent in this course, in the whole course. Okay, so you can see we're approaching negative pi over 2 from larger than negative pi over 2. So what value do we choose? Okay, I just want to show you guys a couple numbers. Okay, so unless for we can also use, you know, I can show you with degree, so you guys can see, can do it and see it for yourself. Okay, you can do it and see it for yourself. Okay, so what are the numbers, right? So what are we trying to observe, right? We're going to observe it from degrees perspective, right? We're also going to observe it from radians perspective. Okay, so once again, we're going to make those tables, right? So we have the angle, and we have the tangent ratio, right? If we look at the degrees, right? If we look from a degrees perspective, sometimes it's much easier to look at degrees, right? So be negative 90 degrees. So what angle do you think is approaching negative 80, negative 90 degrees from larger than negative 90 degrees? That would be like negative 89 degree, isn't it? Is that negative 89 degree? It's larger than negative 90 degree, right? So let's see what is a tangent of 89, negative 89 degree. Let's see what do we get. Okay, negative 89 degree. There, you see, negative 57. So it's going downward. It's negative number, okay? So how about we try negative 89? We're getting closer, even closer to negative 90 degrees. So 89.9 degree, how about that? It's even closer, right? And now what do we get? There, negative 572, negative 572. Wow, do you see that? Okay, all right. So how about, let's do one last one. Okay, I think we have seen enough, haven't we? So I'm gonna remove this column. So this is gonna be 89.99 degree. Okay, to see what the calculation will lead us to. Oh my God, look at that number. Look at that number, so closer, so much closer. It's like you have a sense of negative infinity, right? Do we have a sense of negative infinity? So we can conclude that this guy is going to approach negative infinity. So what do you say about range? What do we say about range? From negative infinity to positive infinity, right? From negative infinity to positive infinity, okay? To help us see even better with radian, okay? So where do you already see the degree? That's great. Let's look at the radian. How are we gonna, get those values, right? So negative pi over 2, the number we're going to choose is going to be larger than negative pi over 2. So we're going to have to add 0.1. You follow me? Okay. So that tangent, okay, that radian, right? What will be the ratio? Let me do it again. Okay, I wasn't sure if this is the right number. Okay, the radian, it's right. Okay, so for input that's closer to it. So next we want to make it even closer to it. 0, 1. Okay, so 0, 1. So what ratio do we get? Even smaller. So in both radian and degree, we see that, what do we see? We see that when we approach negative pi over 2 from larger than pi over 2, or from larger than negative pi over 2, the ratio is getting what? It's getting closer and well, it's going to negative infinity, okay? You see, this is the kind of work you can work with to see for yourself, right? And so that's what happens in this interval between negative pi over 2 to pi over 2. Okay, so as a result, you can see we have seen the domain, we have seen the range, we have seen a piece of the curve, tangent curve. And of course, we have many, many pieces, don't we? We have many, many pieces. Okay, we just see one piece. We just see one piece, right? Do we have more pieces? Of course, if you graph from your calculator, you're going to see many, many pieces, right? So the next point I'm going to just put there on the, just put a little circle for negative pi over 2 to indicate that's not in the domain. Those are vertical asymptote. To wrap up, right? So if we look at the whole of tangent curve, right? If we look at the whole of the tangent curve, and you're going to see that there are many, many periods. There are many, many periods. Say I want to make a negative 7 to 7. So you're going to see more pieces. We're going to see more pieces. And there will be more vertical asymptote. And what are those vertical asymptotes? Well, they are dictated by their what? What are they? In the domain analysis, they are, all of these are vertical asymptotes. All of these are vertical asymptotes. Okay, so we got the curve, right? We got the curve. So all of these are, we have lots of vertical asymptotes. So these are negative pi over 2, x equals negative pi over 2, x equals pi over 2, vertical asymptote, x equals 3 pi over 2, x equals 2. Negative 3 pi over 2, just keep going on and on forever. So this is cosine curve. Domain, range, domain. Okay, so let's summarize. Let's summarize. Domain. Okay, so tangent function, domain. A cannot be odd number multiples of pi over 2. Okay, and the range is from negative infinity to positive infinity. The alternative, okay, another way to express this, okay, another way to express domain, okay, is using 2k minus 1. Okay, that's often used, but I think this one is more common. Okay, so that concluded this lesson about tangent curve, tangent, domain, and range. And thank you for watching. Until next time.